Find the equivalent resistance at terminals A, B in the circuit below. So in this problem, we need to simplify all these circuits into, not all these circuits, all these resistors into one resistor. And we can do that knowing what we know about resistors in series and parallel. Whenever I tackle a problem like this, the first thing I do is identify all the nodes. Before I do that though, I want to point out that at terminals A and terminal B, these 2 points actually act as a node, because when you connect this part of the circuit to another part, these 2 terminals would act as a point of connection, which is by definition a node. Now let's identify all the nodes in this circuit. So on the left side of this 5 ohm resistor, we'll name this node C, and I'm just labeling it to make it easier to reference. Node C. And then below the 24 ohm resistor, I'll label it node D. And if you look at below this 10 ohm resistor, I'll label this at node E. And then above the 10 ohm resistor, this will be one long node, since it's also connected by this wire all the way down below the 40 ohm resistor. So I'll just label this node F. Alright, so now that we labeled all the nodes, let's look at what each circuit element or what each resistor is connected to which node. So if we look at this 8 ohm resistor, we see that it's connected to terminal A and node C. This 10 ohm resistor connected to node B and to node D. 24 ohm to the node above and below, which is node C and D. And I'll just continue to do this for all of the resistors. Alright, 20 ohm to node D and F, 40 ohm to node E and node F, 10 ohm to node E and to node F, the 5 ohm resistor to node C and to node F, and the 12 ohm resistor to node C and node E. So now that we identify all the nodes and circuit elements, let's look at where there are any resistors in series or parallel. So if you look at node A and node B, there aren't any in series or parallel, so it's just connected to one resistor each, respectively. You look at node C, these 4 resistors are not in series, since 2 resistors need to be connected to the node exclusively. And they're also not in parallel as well, since each of these resistors are connected to another node that are different from each other. So the only node they share in common is node C. Likewise, if you look at node D, they aren't in C as well, because there's 3 resistors, and they aren't in parallel since they only share one node together. But if you look at node E, we can actually see that they're not in series. But if you look at the 10 ohm resistor and the 40 ohm resistor, they both share node E and node F, which we define meaning they're in parallel. So these 2 nodes are in parallel. So 10 ohm resistor, and this is the symbol for parallel, is in parallel with the 40 ohm resistor. So these 2 are in parallel. Alright, so when we combine these 2 resistors to form one resistor, we can just draw this new resistor to be anywhere, as long as it connects node E to node F for parallel resistors. So first let's erase these 2 resistors. Actually no, before that, we first need to calculate the combined resistance. So in order to do that, we take the inverse of the sum of the 2 resistors, so 1 over 10 plus 1 over 40, and you take the inverse of that, and we just multiply 1 over 10 by 4 on both the numerator and denominator, so we get 4 over 40. 4 over 40 plus 1 over 40, which is 5 over 40, so that equals to 5 over 40. Take the inverse of that, and that equals to, or simplifies to 1 over 8, and take the inverse of that, so that equals to 8 ohms for our combined resistance. So now let's let's erase these 2 resistance and represent it as one combined resistance. So we still need to keep node E and node F, and I'll write that out again. So this is node E, and we can draw the new resistor like this, as long as we're connecting from node E to node F, or we can draw it straight down, but just for convenience, I'm going to draw it straight across. Alright, and this new resistance is now 8 ohms. So now if we look at this resistor, we can actually see that it's in series with the 12 ohm resistor since they share node E exclusively. So now we can combine these two resistors to 12 ohms plus 8 ohms equals to 20 ohms. So that would be our new resistor. And when we draw out that new combined resistor for resistors and in series, we can actually delete the node in between those two. And when we draw our new resistance, we can draw anywhere as long as it connects to the 2-terminal node, which is node C for the left side of the 12 ohm resistor, and node F, which is the right side of the 8 ohm resistor. So let's delete these two resistors first. And then now let's draw the new resistor. And that would be over here across. And our new resistance is 20 ohms. Now to simplify things again, we can actually see that this 20 ohm resistor is connected to node C and node F, which is the same as this 5 ohm resistor. So these two resistors are actually in parallel. So we're going to find the value of the new resistance by doing the same calculation above. And so let's do that, taking the inverse again of the 1 over 20 plus 1 over 5. And if we simplify it, 1 over 5 times 4 on both sides, which is 4 over 20. So 4 over 20 plus 1 over 20 equals 5 over 20. Inverse of that, and 5 over 20 equals to 1 over 4. So 1 over 4, inverse of that, which equals to 4 ohm. So our new resistance in parallel is the 4 ohm resistor. And again, we're going to repeat, we're going to erase these two resistors and then connect one resistor together. So erase these two. And yeah, as long as we have this resistor. Alright, so let me draw this node again. That's the node, and we're drawing out this new resistor. Let's just draw it like this. Nice. And this is our 4 ohm resistor. So 4 ohm. Alright. And now we can do the same calculation again. Or not calculation. Now we can same process and see whether there are any in series or parallel. And we can actually see that this 4 ohm resistor shares node F with this 20 ohm resistor, and they share it exclusively. So these two resistors are in series. So now let's combine them. Let me scroll down for more space. So we just added those two together. So 4 plus 20 equals 24 ohms. And as usual, we can just delete the node in between and just connect it, in this case, from node C to node D. So let's erase again. So now we don't need this node F anymore. So now let's connect these two resistors. These two resistors. And they're combined to make a 24 ohm resistor. And if you look as well, it's actually in parallel with this 24 resistor is actually in parallel with this 24 ohm resistor as well, since they both share node C and node D. So we can actually combine them to form one equivalent resistance as well. So if we do that, let's see, a different color, you see that the inverse of 1 over, my bad. You see that 1 over 24 plus 1 over 24, take the inverse of that, equals 2 over 24, which is equals to 1 over 12. and take the inverse of that, so we get a 12 ohm resistor. Alright, so now again we can delete these two, and just as long as we create a resistor between node C and node D, it should be fine. So let's erase this part, but we still need to keep node C and node D. I'll just jump over here. So this would be node, let me draw it. This would be node C, and our resistor would be, as we calculate below, 12 ohms. But as we can see that these three resistors are actually in series, since the 8 ohm and 12 ohm resistor share node C exclusively, and likewise the 12 ohm and 10 ohm resistor share node D exclusively. So we can actually add these two resistors together. So 8 plus 12 plus 10, so that equals 8 plus 12 equals 20, plus 10 equals 30 ohms. So our equivalent resistance at terminals A, B is 30 ohms, and that is our final answer.